Hey Algebra 2, we are continuing on with our lessons on logarithms. Today we're going to talk about the WhatPower. This is sort of how we think about logarithms as we're building our knowledge base. So hopefully you think this is a little bit fun because it's a great way to think about logarithms to figure out what we're supposed to do with them. Cool? So first of all, we have a million opening exercise problems. So I'm going to do the first page and let you guys do the rest of them on your own. This first one says, what power base 2 of 8 equals 3? So it's really, how I've always set these up, it's really 2 to the what power equals 8. Okay, so this is what you're trying to solve, the what power. All right, so for that one is 3. The next one says 3 to the what power equals 9. So again, that's what we're trying to solve. Let's try the next one. 6 to the what power equals 36. Well, we've got 2. 6 squared is 36. 2 to the what power equals 32. I think that's 5 or 6. Hold on a second, let me double check. It's 5, because I think I got that one wrong on the last lesson and didn't realize it until I'd already moved on. So that happens. 10 to the what power equals 1,000. Well, we have 3 zeros, so that's the third power. 10 to the what power equals 1, 2, 3, 4, 5, 6. 1 million, that's the sixth power. Cool? All right, the rest of these you guys are going to do on your own and just check your work. I'll go to the next page. Go ahead and push pause though, okay? Push pause. Let's check our work. All right, here you go. Check them over. I did a few explanations for the somewhat trickier ones. And circle it if you're not sure why the answer is what it is. Okay, 2 more. I'm pushing pause. And there's the last 2. Tad bit tricky, but not impossible. Oh, did I miss one? Oh, I think I did. Sorry. Let's do XVI. That is what power to the 1/4 2 equals something. So that's going to be 1/4 to the what power equals 2. So I need to get that up to the numerator. So it's going to be negative. And then I have to take the square root of it. So negative 1/2. So 1/4 to the negative 1/2 equals 2. Because that gives me 4 to the 1/2 is positive equals 2. So that is my answer for that one. Cool? Oh, there it is. Haha. So with your group members or just on your own, unless you have people at your house, write a definition for the function what power base b, where b is a number. Well, what we just did was b to the L equals x. So L equals what power base b of x. All right, so the value of what power is the number you need to raise b in order to get x. So b to the L, the number you're looking for, equals x. So L equals what power base b of x. So these go back and forth. All right. Okay, there's really no change with the exercises we're going to do, except I'm not going to write them. It's what power base 7 of 49. So we do 7 to the what power equals 49. So we're still doing 2 because it says justify your answer, so I'm gonna. 7 squared equals 49. So what power of base 0 is 7? So 0 to the what power equals 7. Yeah, that doesn't work. Okay, I can't raise 0 to any number and get an answer that would be 7 at all. Okay, it just doesn't work. This next one, though, I have 5 raised to the 0 power will equal 1, because anything raised to the 0 power is 1. So that one works. And there's my reasoning. And then, oh, this one's odd. So 1 raised to what power equals 5? Yeah, that doesn't work. I can't raise 1 to anything and get anything else other than 1. I mean, 1 raised to anything is going to be 1. Anything at all. So that doesn't work. Let's keep trying them. So -2 raised to what power is 16? Let's try that one. So -2 raised to what power is 16? Well, I do know that 2 times 2 times 2, 4 times equals 16. But if I do negative, let's double check that. So I'm going to put parentheses -2 raised to the 4th power, and I get 16, so that works. That negative can throw you for a loop, so if it were something raised to a 3rd power, it would remain negative, like this one. -2, so 2 to the 5th power is 32, but -2 to the 5th power is -32. So that one doesn't work, right? Raised to odd powers, your negative stays negative. Raised to even powers, your negative multiplies to be positive. Let's try this the next one. I've got 1/3 equals 9. So 1/3 raised to what power? Well, it's going to be a negative exponent, so I can get that 3 back to the numerator. And I'm going to have to square it. So -2. Because 1/3 to the -2 equals 9. And how about this one? -1/3 to the question mark equals 27. Well, that's not possible either, because this would have to be a 3, well, a -3. But well, erase that. -1/3 to the -3 would give me -3 to the 3. I just used that negative exponent to bring my 3 back up to the numerator. But -3 to the 3rd power is -27. So that one doesn't work. Okay. Number 9, describe the allowable values of b in the expression what power base b of x. When can we define a function f of x equals what power base b of x? Explain how you know. If b equals 0 or 1, that's when we're having issues, right? So that when b equals 0 or 1, the expression what power base b of x doesn't work. It doesn't make sense. If b is less than 0, so if b is negative, then the expression what power base b of x works for some values of x, but not all. I have one more thing to say about that, though, so I need a new slide. Follow me along. Oops, so continued on when the b is less than 0. So we said that it works for some values of x, but not for others. Therefore, we cannot define a function. So we can't set parameters. We can't define a function f of x equals what power base b of x if b is less than 0. But what's cool about that is, therefore, we can define the function f of x equals what power base b of x if b is greater than 0, right? And b is not equal to 1. So that's what we're looking for, okay? Okay, just talking about this was the exercise and the rules that we're trying to develop, right? Let me just summarize one more time to make sure we're all on the same page, because it's an important thing about logarithms. Our base, b, just has to be restricted. Let's try to clear it up. So this is where b has to be. It has to be in between 0 and 1, or it has to be greater than 1, okay? Nothing really in between. So that's how we need to restrict b. Now, why are we doing this WhatPower baloney, right? The WhatPower, which as you notice I've abbreviated, is known in math world as a logarithm. It's some history. It's built from the Greek word logos, and it means ratio. Some interesting things. And then it's also built from the Greek word arithmos, which means number. That was a B there. Let's rewrite it. So ratio, number. The number b is the base of the logarithm. It's the base of the logarithm. So we denote the logarithm base b of x. So we say logarithm base b of x. That's what you hear me say as I talk about the problems. So that means we would write logarithm base b of x. And that's how it's written. You can put parentheses around this. I may go back and forth. I'm not really used to putting parentheses around it, but what we'll see in all of our work is parentheses around it. So when we see this log base b of x, it's really saying what power base b of x. Cool? All right, let's move along. Okay, if we get into a definition of the logarithm base b, I just gave you log base b of x equals L. I grew up saying log base b of x equals y, but that's okay. We can use different letters. These two are equal, so that means b to the L equals x. To give you a few just really simple examples, I can say log base 2 of 8 equals 3, because 2 to the 3 equals 8. Log base 5 of 1 equals 0, because 5 raised to the 0 power equals 1. Or log base 10 of 0.01 equals negative 2, because 10 raised to the negative 2 equals 0.01. See how they just go back and forth? So those are great examples. So I've got my definition. Oh my, I'm not sure what that was. Definition. And some examples. And now how about some characteristics? So we have if b is greater than 1 and x is greater than 1, then log base b of x is going to be greater than 0. So our base is greater than 1, our x is greater than 1, so our log base b of x will be greater than 0. How about if b is in between 0 and 1 and x is greater than 1? Well, that just means that our log base b of x will be less than 0. Okay, these are the two characteristics that we are going to see, right? And as a reminder, logs that don't work, that aren't possible. Not possible. would be an example like log base 0 of x. Nope, can't do that. Because 0, nope. Because 0 raised to some power can't be anything other than 0. And then log base -1 of x, that doesn't work either. Okay, -1 raised to some power is not going to be x consistently. Remember, if we had, you know, positive power, negative power, sorry, odd power and even power, we would get the correct answers, but it's not consistent enough to be defined. And then log base 10 of -2, that doesn't work either, because 10 raised to some power, I'm not always going to get a negative. Well, I would never get a negative answer. Okay, so those are some problems, some non-examples, okay, not possibles. So here's some examples. It's what you've just seen, except we are no longer using the word WhatPower, we're using the abbreviation log. So it's exactly the same. Go ahead and try them. I'm going to push pause and then you can go ahead and check your answers, but we should be able to get through these pretty well. Okay, I didn't give you the whole 6 squared equals 36. We're going to start practicing doing these in our head, so I'm not going to always write them out for you, but we know the rules. We know that we have log base b of x equals L, which is b to the L equals x. So you can go back and forth and figure them out. Okay, I think we have some more, so let's try the next ones. Oh, I missed these, sorry. I cut them into a new slide. So this first one's going to be -1. And then this next one is going to be 2 to the what power is 1/4 -2. I need to flip that 2 to the denominator and then square it. Cool? Alright, now try these. Verify your answers using an exponential statement. So they do want both of them like this. We're going to say equals 5 because 2 to the 5th equals 32. Okay, I think we've already done that one like 4 times, but it's okay. We'll do it again. Okay, try these next ones and go ahead and write your because statement. All right, check these out. You can push pause and look at them. I'm going to move on. Okay, next we have these. I've got 1 because 13 raised to the first power is 13. Duh. I have 0 because anything raised to the 0 power is 1. 1/2 because 7 raised to the 1/2 is the square root of 7. And then this one is throwing me for a loop. So I'm going old school. 9 to the what power equals 27. Let's see. If I do 9 times 9 times 9, I get 729. So 9 to the 3rd power is 729. And I think if I take the square root of that, I get 27. So that means I'm cubing it and then taking the square root. Cool, that was a tough one. Because 9 cubed square root is 27. Awesome. A few more. Oh, we already did this one. And that one. Right? J? Oh, we didn't do K. We did one very similar to K. Hold on, erase that. So for K, that's going to be 2. Because the square root of 7 squared equals 7. All right, this one's a little tricky. I'm going to go ahead and go over here, and try to figure it out. So actually I'm trying to get like 7 to the 1/2 raised to something equal to 49 to the -1. So 7 to the 1/2, to get that to 49 would be, I need to go 4 halves, because that would be 7 squared. So right now I multiplied it by 4, but I also need it to go negative to get to the denominator. So I need to multiply it by -4. I think that'll work. Because 7 to the 1/2 raised to the -4 power gives me 7 to the -4/2, which is 7 to the -2, which is 1/49. That works. Awesome. That was a little tricky, wasn't it? How about this next one? I have x raised to what power equals x squared 2. Okay, it's no different with the variables. All right, they work the same way. So there's our rules. We've written them down a few times throughout the lesson, but just summarizing it so that you knew what we did today. And we'll work through our problem set tomorrow. Good job.